So I'd like to give a talk about comprehension of business process models via an eye-tracking approach. Why tokens? So tokens is a method to animate process models. So 4 parts: extant literature, gap, objective, then methodology, results, and a discussion. So in briefly, so business process modeling, I understand this as a translation of textual requirements into visual format. Of course, there's different interpretations, but for delimitation, we focus on this. So it's both on making and reading a model, and we focus explicitly on reading a model via tokens, so comprehending via reading. And comprehension of process modeling is one of the most critical elements to actually realize the benefits of business process modeling in the business, in the actual organization. And it's typically studied via experiments in large-scale experiments of 200, 300 participants, and also an eye-tracking approach, which is usually by 25, is considered a statistically significant sample size, and it's more qualitative oriented, right? And so learning of process modeling, it's a complex activity, and acquisition of skills of abstraction, conceptualization, is typically not so easy to implement. And from our research, we find that it's typically because of a lack of broader conceptual modeling skills. So we had this discussion about the systems thinking, and in general, this is a lacking skill to build up. So the students, they see it as of the first time. While, for instance, in science modeling, they build it off from the high school on atomic models, chemistry models, so they know conceptual modeling. And so they continue on these places. So that's a challenge. And animation in process modeling, it's an additional and typically not formalized relation, right? So there's no definition of the color of the token and the speed of the token and all of those things. They are important from the cognitive perspective of actually comprehending the models, right? So that's an unexplored topic. On animation specifically, on the eye tracking, on how the different patterns are actually being studied, right? So you can ask students qualitatively, but eye tracking, it's actually physiological based data. So you have a direct access to the comprehension, to the psychology. And it's also related to visualization information and simulation, but of a few selected cases, right? So it's not large-scale quantitative simulation, but more or less like individual cases, and how this can translate into better comprehension. So the cognition frameworks, I will briefly discuss this. So usually comprehension is done via cognitive load theory, right? So you have sensory inputs, you have working memory, and there you have cognitive load. So the higher cognitive load, the higher your capacity to operate with the mental objects, right? And it's somehow integrated with the long-term memory, right? So that's one approach, but we more follow like distributed cognition approach. One which subsumes this cognitive load, but it also suggests that external resources, such as the type of animation, how you interact with the animation, that is not least important, right? So your cognitive load, right? You're a brilliant person, but you're not able to actually extract this information. So this hinders your comprehension process. And so we follow this this approach because it allows us to perceive this subject of human model interaction more broadly, right? More from the design perspective. And so research gap, even though animations were shown to improve comprehension, there's yet no research on using eye tracking for studying animations. So we find that the research gap, and the research objective is to cover the gap by performing first step, exploratory, qualitative driven research into this topic. And so we compare static models with the animated models by tokens. And by the way, there's different types of animations. I like also highlighting, but we focus on tokens as one of the more popular methods. And so the two research questions, pretty simple. Is there any differences between model reading patterns based on eye gazes between static models and animated models? And if so, what can the differences imply for process modeling education? So it's more qualitative oriented, and we also have a strong pragmatic component to this paper. So methodology. So we adopt an eye tracking approach, a small sample size. So an eye tracking device, it's essentially like in here you have this small blank which records your gazes, like you sit before the laptop, right? And so it records your eye gazes as you interact with the model. And it has all the fixations. So you look at one place, it records statistical data, then in another place, and then based on this comprehensive analysis, you can draw some conclusions based on the patterns, how you interact with the model. It's widely used in marketing. It's also used in user interface analysis and user experience, right? So it's like very, like it's coming from that, and it's also used in comprehending how students comprehend static models, right? But not for animation. So that's the eye tracking equipment. It's a pretty old one, so we are going to do more research on a different one, so, but it still works. We had videos, because one problem was that there's no such software for eye tracking on animations, interactive animations. So we devised a low interactivity video, right? So low interactivity animation, which is essentially video animating some process, pre-recorded process. So we had 7 participants, and then we had demographic data. We trained the students how to interact with the eye tracker, right? They answered static model first, and then they had the option to view the animated model, and then maybe to correct their answers, right? So after having first made an answer, they had an option to correct their answer. And then we had a qualitative feedback. So that's more or less how it looked like. So static model, intermittent, okay, it says here, okay, like you can go to the next screen, they view the model, and then they're shown again the static model, because the video, it's a design option, like, right? So we didn't decide to play it infinitely, so they were at the static model, but they could replay it. So we adopted the questions from Eisenman and Reyes and Maslov and Poilmans. So those models were quantitatively, they were shown to show higher comprehension scores, right? So you ask the question, can this happen? And in animated condition, there is a higher, like significantly higher percentage that this animation can really improve your correct score. So 4 abstract models, 20 to 30, and 4 models with semantically meaningful process tasks. So we decided to split it, and also the complexity was more or less average. So semantically meaningful content, it had fewer nodes, but it was still complex to understand, nevertheless. And so every model typically had only one question: can this happen? How many times this process activity will be activated, and so on. So this is an example, right? So that's what the students saw while they were interacting. So there's a token, there's this flowing, and this scenario was pre-recorded. By the way, this was one of the discussions we had. Okay, so like since design decisions, what path to animate, it's not neutral, right? So it's already some sort of a bias. So if you, that would be one of the findings, that if you sort of are interested to explain this work of inclusive gateway, right? Because this is essentially telling you that several tokens can pass through. And so given the condition, it can really improve your focus on this specific relevant part. So we try to adopt it, but not so significantly. And in the future experiments, we think more carefully how to really structure the animation so that students can really understand what's being shown. This can be important for PowerPoint presentations, for instance, when you don't actually interact with the model, but simply show this is the token. And so the results. There are specific statistics in eye tracking research, but more or less it's, It's quite technical and can be a bit challenging to understand, but more or less it's the number of fixations, so how many times do we look at a certain area of interest, and the dwelling time in a given area. And the higher dwelling time, it can signify either higher cognitive load or a higher importance for the area, right? And the areas of interest, I forgot to mention, for instance, this is completely subjectively designed, like which area of interest is important. So we decided that this is an area of interest for the answer, right? Because here's an answer area where you have to answer. And this is the scenario. And well, depending on this, you can actually analyze what's the difference, like what do you actually focus on. And the correct answers are also higher, because after they viewed the animation, it improved their correction of their answers, right? But it also had 2 times lower on typical eye-tracking metrics, right? So after they first answered with the static model, they actually had fewer eye-tracking metrics after they viewed animation. And this is more interesting. So since it's more qualitative driven, we have analyzed the eye gazing patterns. So this is the first part. So they viewed the static model. There's all over the place, all over the model, the students, they were analyzing all of the different paths, question areas, so they were really focusing on it. In the animated video, they focused only on the relevant paths. So we observed some effect of animation really pinpointing the comprehension, the attention of a modeler to really the right places, right? So that's where they focused. And then after they view it, they forget about this part, so they mostly used only the question area to think of. And this is an effect of how tokens can actually somehow change your cognitive patterns in the future. So they sort of imprint, we hypothesize, but it's for future research, but we hypothesize that without tokens, it's more or less unstructured, right? So this is more like a triangle. So they ignore this area, there's the answer, so unstructured. Here, so the token flows like in this square, right? Here's the higher focus, and without the animation, in the static, we observe the similar pattern, right? So it's sort of like sticks, right? So you show a certain token, a token path, and they sort of like remember almost at the habitual level, right? But it's for further investigation, but I think it's very interesting. It can teach like right cognitive procedures, right? When you're driving a car, you're not thinking how to drive the manual, for instance, and this is more or less similar thing, right? And then we also had qualitative feedback. So the qualitative feedback, it sort of clarified what we observed. So it had potential for simplifying, it was engaging and interesting, so it allowed for exploration, it helped the students to understand individual symbols, patterns, and they also created their own scenario, right? But at the same time, it was also, it's not so one way, because also if you make a mistake first, then it's easier to correct the models. I mean, like if you make a mistake first and then you view the animation, like you see your error, and then maybe it's better for your long-term learning after you actually make an error. So maybe it needs higher interactivity. So that's what we plan to do in the future research, to promote higher interactivity on eye tracking, on animation. And maybe sometimes unnecessarily complex for simple models, you just don't need it if you know BPMN, right? So we observe differences. Eye gazing patterns, they differed. And animated models, our final finding, let's say, it's sort of is a sort of external cognition device. So if you use correctly, it can really improve your goals of as an educator, right? So you need to teach a certain pattern that really helps to, if you guide it correctly, then it can really help the comprehension of this select pattern, right? So it's a scaffolding device. device. And well, implementation. So that's the final part. So the four main things that we identified. So the students, they follow the token, like if the token is here, so they follow it. They can also create new scenarios mentally, right? So like they imagine new scenarios, and this can help their exploratory of that model. They comprehend the pattern, as I discussed, and they also help to answer questions. So it's sort of like if you give this tool, and then the students, they actually try answering exercises at home, it can help them in self-correcting, let's say. Right? In sample size, like threats and validity issues, so sample size is qualitative, experiment design, it's sequential approach, and selection of models, it can be also improved. And interpretations, obviously it's a qualitative interpretation, but we also followed some of the advice on promoting transparency and internal validity and validity in general of qualitative research. So it's accessible on the net, right? Yes, and some future research, larger sample, interactive models. So we are in the process of this, developing a new software. And yeah, there's actually a lot of different discussions we can actually aim, right? Because animations, they are really, for some reason, an unexplored subject of how to actually use the animations for comprehension, for learning, and that's which we aim to discover in the future. Yes, thank you very much.